Hello, we're Team 7 studying Burj Arab. This week, every member did their research and study about this week's material, and Woongjin also participated as the second presenter. Now let's start our 11th presentation. Starting with a quick review, we'll move on to this week's episode and construction about the finale of Burj Arab's construction.
Last week, we have learned about how critical wind loads are to the high-rise buildings such as Burj Al Arab. When the wind load is applied to the structure, it creates vortex shading caused by the separation of airflow. Vortex shading creates vortex-induced vibration, which could cause various problems. Structural engineers figured out that Burj Al Arab was also exposed to vortex vibration by carrying out wind tunnel tests, and they had to find solution for it. Their solution was installing tuned mass damper, also known as TMD. TMD absorbs the transfer energy caused by external force, and by that it could decrease the vibration. TMD was installed in total 11 points in Burj Al Arab's exoskeleton and effectively decreased the vibration. With that, Burj Al Arab could be an iconic and structurally stable building of Dubai.
Now then, what's left for Burj Al Arab until its grand opening? We studied how experts in various fields solve the many problems that have occurred from the construction of artificial islands to the exoskeleton. Burj Al Arab was now at its final stage, but still there were problems that had to be solved. By the time construction began and almost reached 4 years, which was in the early 1998, Burj Al Arab reached 60% of the construction work. It was going on without much trouble, but there was no time to spare. The client had emphasized from the start that the hotel must be completed in time for the year 2000. Therefore, the remaining 40% of the construction had to be completed in less than 2 years. What's left of the 40% was the installation of the fabric wall in the front, the interior, and the structures on the high level. If these works were done separately, it would possibly take more than 3 years until completion. For that, the final work of Burj Al Arab was done simultaneously. There were many constraints and were basically complex tasks, therefore systematic sequence and methods of construction order were needed and had to be proceeded quickly. Let's find out how each parts were completed. To start with, the construction team chose prefab method to install exoskeleton and the room unit at the same time. But humidity in Dubai reached 100% and temperatures could soar up to 49 degrees. These conditions simply won't allow the team to fit delicate finishes like gold leaf, silk, and carved wood, so they had to find solution for it. The construction team proceeded the 2 tasks in advance in order to start the interior. It was first securing airtightness of buildings and then reducing humidity and temperature to the certain degrees. To secure the airtightness, they installed fabric wall, which also symbolized the sail. This wall not only worked as a symbol, but also could resist dirt and sand by pre-coating the surface with Teflon. The reflective properties of this white sail also helped with keeping the temperature down. However, the contractors still needed to find a way for installed trucks to enter the building without allowing the desert heat. Therefore, they installed a huge airlock. When the truck drives in, the vehicle pauses as the door closed behind it. A second set of doors then open, and the vehicle moves out of the building. The airlock and the fabric wall could now fully enclose the building. But cooling the space between the fabric wall and the core during construction could create a major setback. The atrium they were about to cool was the world's largest. All this warm air can hold far more water vapor than cold air. If they cool this hot, humid environment too quickly, it could create uncontrollable condensation, a rain cloud at the top. The only way to avoid rain clouds cost time. The contractors brought a giant cooling system and decreased the temperature steadily by less than 1 degree a day. They started to cool the building down in June of 1998, and almost by December, it reached the temperature they wanted. Now the two tasks were completed, the interior decoration could begin. But finding the designer who could satisfy the client's taste caused additional delays. They hired Kwan Chu, who had experience with the client beforehand. The client required a modern and utmost design for the Burj Al Arab. To fit the schedule, Kwan Chu worked with 50 designers for the interior. While Kwan Chu was struggling with the interior, the helipad was being built at the top part of the building. By connecting the exoskeleton rear leg with the spire of the core, it naturally created a space for a helipad and the entrance. It's located 212 meters from the ground and weighs about 330 tons. How it's hanged, circular steel pipes with diameter of 1 meter created an upside-down V-shape and connected with the center core with 40 meters spine truss. At the front of the building, helipad was being constructed, while at the back, the toughest engineering challenge was beginning. It was the construction of the Sky Restaurant. The Sky Restaurant is located 200 meters above the sea, weighs almost 200 tons, and is projected nearly 30 meters from the building's narrow core. The engineer finds a solution to this tough work. In the concrete core at the back of the building, he casts a series of steel brackets known as embedment. 10 enormous steel girders of 30 meters radiate them up to 1.6 meters high. These beams form the base of the rigid steel floor. The wing-like exterior could be attached to it, and then the entire restaurant is enclosed in aluminum and glass. This gravity-defying structure will survive winds of close to 160 kilometers an hour. With its fabric wall, interior, helipad, and sky restaurant completed, Burj Al Arab was now at its grand opening. However, the world's best hotel couldn't be satisfied with its original state. After its opening, they constructed additional features, and next week, we'll learn about what those structures are. Thank you for listening.